So let's take a look at number 1. It asks to write the first 5 terms of the sequence, assume n begins with 1. So we're just going to plug in 1, 2, 3, 4, and 5. So a sub 1, we plug in 1. So 8 times 1 plus 6, which would be 14. And then a sub 2 would be 8 times 2 plus 6, which is 22. A sub 3, we plug in 3, plus 6, which is 30. A sub 4, we plug in 4. What do we get? 38. And then the last one, a sub 5, we plug in 5. What do we get? 46. So our first 5 terms are 14, 22, 30, 38, and 46. So even though these are the first 5 terms and this is what it asks for, you still have to show your work. So I still need to see all the work. Thank you. I need to see you plug it into each one. All right, let's take a look at the second one here. So we're doing the same thing. Start by plugging in 1, so we get 3 times 1 over 1 squared minus 2. So this would be 3 over 1 minus 2 is negative 1. So what do we get? Negative 3. But sometimes you may see it like that. So you don't have to. You can write it either way. Alright, so we plug in 2, we get 3 times 2, 2 squared minus 2. So 3 times 2 is 6. 2 squared would be 4, 4 minus 2 is 2. And how do we simplify 6 over 2? 3. Yes. Yes. So when I plug in 3, I have 3 times 3 over 3 squared minus 2. So this is 9 over 3 squared is 9, minus 2 is 7. Can I simplify this one? Nope. Then we plug in 4. So I have 3 times 4 over 4 squared minus 2. So 12 over 16 minus 2 would be 14. Can I simplify this? 6 over 7. And then a sub 5, we plug in 5. So 3 times 5 over 5 squared minus 2. 3 times 5 is 15. 5 squared would be 25. Minus 2 is 23. Can we simplify that fraction? Nope. So our first 5 terms are negative 3, 3, 9 over 7, 6 over 7, and 15 over 23. Going back to number 1, what type of sequence do we have here? So the first one, what type of sequence? Arithmetic, because we're adding what to get from one number to the next? We're adding 8. So because there's a common difference, it's an arithmetic sequence. What about for the second one? What type of sequence? Is it arithmetic or geometric? Am I multiplying by the same number each time? Or adding the same number each time? Nope, I'm not. So this would be neither. So it's neither arithmetic or geometric because it doesn't have a common difference or a common ratio. All right, number 2. Find the indicated term of the sequence. So here it asks us for the 16th term, so we just plug in 16 into all of our ends. So 16 squared over 4 times 16 minus 3. 4 times 16. There. So what is 16 squared? 256. And what is 4 times 16? 64? So 64 minus 3 would be 61. Can I simplify this? No. So this would be our 16th term. If the question on the quiz says no decimals, what does that mean? We keep it as a fraction, so you would leave your answer just like this. If it says exact answer, you leave your answer just like this. Exact answer is the same as no decimals. Any questions here? All right, right below. Here, we're finding the 19th term, so same thing as the last one. So a sub 19 is equal to negative 1 to the 19th minus 1 power times 19 times 19 plus 1. So this would be negative 1 to the 18th power. What's negative 1 to the 18th power? Positive 1. And then this would be 19 times 20. So what's 1 times 19 times 20? 380. Awesome. All right, number 3. Write an expression for the apparent nth term of the sequence. Assume n begins with 1. So what type of sequence do I have in the first one? Am I adding the same number each time or multiplying the same number? I'm adding the same number. What am I adding or subtracting? Negative 5. So I'm subtracting 5 each time. So I can find what my 0th term is, because this would be my first term. So what do I do to go backwards to find my 0 term? Add 5, because I subtract to go forward, so I would add 5 to go backwards. So what's negative 3 plus 5? 2. So how would I write my expression? an equals negative 5n plus 2. So remember, our equation here is an is equal to d times n plus a sub 0. Or you could use the other one, which is an is equal to a sub 1 plus n minus 1 times d. When you simplify this, you'll end up with the same. Any questions here? All right, so in the next one, remember we said this number should be 4. So what am I adding to get from one term to the next? 3/2. We can always find that out by taking the second term and subtracting the first term from it. So if I did 1 minus negative 1/2, this becomes a plus. So I can make this 2/2, so 3/2. So my common difference is 3/2. I'm adding 3/2 each time. So to find my expression, I want to find what my 0 term is. So what would I need to do to go backwards? Subtract 3/2. So if I had negative 1/2 minus 3/2, what is this? Negative 4/2, which is negative 2. So my 0 term is negative 2. So how would I put this in an expression? A sub n is equal to 3/2n minus 2. Perfect. Number 4, we're simplifying the factorial. So here, this would be 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 factorial. Once we get there, we can stop because I have a 9 factorial on the bottom, so I know these are going to cancel. So then in my calculator, I'm just multiplying 18, 17 all the way through 10, which you'll end up with a really, really big number. I think most people's calculators gave them like a e to the 10th power or something. That you can, so like the calculator gives you like 1.7 something, and then times 10 to the, I don't remember what power it was. Do you have it written down? To the 10th power? Something like that. So how we would do it is just move the decimal 10 times. So that would be our answer. But your numbers on the test will be smaller, so it'll give you an actual number. So you won't have anything this big where it'll give you the scientific version of it. All right, let's look at next one. So here I have 12 times 11 times 10 times 9 times 8 times 7. I'm going to stop there because I see that I have a 7 factorial on the bottom. So I know that those will end up canceling out. And then I have a 5 times 4, and I'm going to stop at the 4 factorial because I see I have a 4 factorial on the bottom also. So the 4 factorials cancel and the 7 factorials cancel. So in my calculator, I'm just multiplying 12 times 11 times 10 times 9 times 8 times 5 here. So what do I get when I multiply those together? $475,200. So again, on the test, if it says exact answer or if it says no fraction, make sure you know how to simplify it this way, because if you put it all in your calculator and you end up with a number on the bottom, you may have a fraction. So just make sure you know how to leave it as an exact answer. So know how to simplify it. Any questions here? All right, number 5. Find the sum. So a couple different ways we can do this. Is this an arithmetic sequence or a geometric sequence? It's arithmetic. It looks just like our arithmetic formula. We have a number times our variable minus another number. It looks just like it. So since we know this is arithmetic, I can use my arithmetic sum formula, which is S sub n is equal to n over 2 times the first term plus the last term. We could also do this by plugging in 1, plugging in 2, 3, 4, 5, 6, 7, and 8, and adding them all together. But in my opinion, the formula is going to be a little bit easier to do because there's a good amount of numbers here. How many numbers do we have to plug in here? How many numbers do I have from 1 to 8? 8, because I'm including 1 and 8. So to find your n, to figure out what n is, you would do the first, or you would do actually the last minus the first. Last minus first plus 1. So this would be 1 minus 8 plus 1, which is 8. Yeah, but if your n's like 200 numbers, you can't sit there all day and add up 200 numbers. So you may need to use the formula. So n is 8. So I'm finding S sub n is 8 over 2. How do I find what a sub 1 is? Plug in the first number that it asked me to here. So a sub 1 is going to be equal to 8 times 1 minus 5. So 8 times 1 is 8. 8 minus 5, 3. How do I find what a sub n is? Plug in 8. So I plug in the last number here. So a sub 8 is equal to 8 times 8 minus 5. So 8 times 8 is 64. Minus 5 would be 59. Mm-hmm. This should be 8 minus 1. You're right. Because it's the last minus the first. So using these numbers. When it's a number like starting with 1 and ending with 8, we can easily see that it's 8. But if we started with something other than 1, we may need to, because we can't sit here and count if it was a really big n. There were a lot of numbers in between. So to find the sum, this would be 4 times 62, which is 248. Anybody agree? Disagree? Let's look at the next one. What type of sequence do we have here? Arithmetic. Because, again, I'm multiplying my number by a coefficient, or I'm multiplying my variable by a coefficient, so this would be arithmetic. If I had an exponent, then it would be geometric. So I'm going to use my sum formula again. So S sub n is equal to n over 2 times the first term plus the last term. Now this one, to find n, I would do the last, so 7 minus 3 plus 1. So how many terms do I have here? 4. I have 5 terms here because 7 minus 3 would be 4 plus 1 would be 5. So if I count it, I'm plugging in 3, 4, 5, 6, and 7. So I'm plugging in 5 numbers. So always subtract them and add 1 because you're including both of these. So n is 5. So I have S sub 5 is equal to 5 over 2. How do I find my first term? Plug in what? Plug in 3. I plug in my first number. So a sub 1, or it's actually a sub 3 here, is equal to 1 over 3 times 3. So what would this be? Yep, 1. And then how do I find my last term? Plug in 7. So I have a sub 7 is equal to 1/3 times 7. So this would be 7/3. So S sub 5 would be 5 over 2. I'm going to change this to have a common denominator to make it 3 over 3. So it would become 10 over 3. And then when multiplying fractions, remember we multiply straight across. So this would be 50 over 6. And how can I simplify this? Divide by 2 on the top and bottom. So 25 over 3. So again, I could plug in all 5 numbers. I could plug in 3, 4, 5, 6, and 7 and add them all together. That would work too, but if your n was something really big, you have to use the formula. All right, let's look at number 6. It asks us to find a sub 47 and a sub n given a sub 12 is 13, a sub 18 is 31 of the arithmetic sequence. So it tells us that it's arithmetic. So how would I set up my first equation?
Find the difference between the farther term and the closer term.
Perfect. I find the difference between 18 and 12. So how many numbers do I have? 18 minus 12. 6. So I start with my term farthest from 1. So a sub 18 is going to be equal to a sub 12 plus the difference. So that would be 6 times the common difference. I know what a sub 18 is, and I know what a sub 12 is, so I'm going to plug those in. I have 31 is equal to 13 plus 60. Subtract 13 on both sides. So this would be 18 is equal to 60 divided by 6. So what's D?
3.
D is 3. Our common difference is 3. Now, how can I find the 47th term?
Find your a sub n formula.
Okay, I can find the a sub n formula.
What I did is I worked backwards, so I plugged in my a sub 13.
We can do that. So a sub 12 is equal to a sub 1 plus, what's the difference between 12 and 1?
11.
11. So it's just 12 minus 1. And then what's our common difference? What's D? 3.
3. Oh, wow.
So here, I know what a sub 12 is. That's 13. So I have 13 is equal to a sub 1 plus 33. Now I'm trying to figure out what my first term is. That way I can plug it into my a sub n formula. So subtract 33 on both sides. So what's a sub 1 equal to? Negative 20. So in my a sub n formula, it's a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to, what's a sub 1? Where did I get what? By subtracting 1 minus 12. Because in our formula here, notice for this one that it's n minus 1. So that works for everything. That's why we do 18 minus 12 and get 6. 12 minus 1 and get 11. So we can plug in whatever we want for n and 1 and just subtract them. So then plus n minus 1. And what's d? 3. Now I can simplify this a little bit. I'll distribute the 3. So a sub n is equal to negative 20 plus 3n minus 3. And then combine like terms. Be careful, these are on the same side, so it's not like you're adding 3 to both sides, you just add them, combine them together. So it would be 3n minus 23. And then the last thing it asks for is our 47th term. So we just plug in 47 into n. So 3 times 47 minus 23. What do we get? 118. So the number that gets multiplied to d always comes from subtracting these two. So here, n minus 1 is n minus 1 that gets multiplied to d. So it comes from the formula. It's the same formula that we're using. So let's take a look at 13. So use the formula for the sum of the first n terms of an arithmetic sequence to find the indicated term, or the indicated sum. So it says that it's arithmetic, so it's the arithmetic sum formula, which is a s sub n is equal to n over 2 times a sub 1 plus a sub n. So how do I figure out what my n is? Last minus first plus 1. So what's n equal to? 30. 30. 30 terms in here. So I'm going to plug that in. We're finding the sum of my 30 terms. So it'll be 30 divided by 2. What's a sub 1? How do I find it? Plug in 1. So I plug in the first number down here. So a sub 1 would be 3 times 1 minus 6, which would be
93.
-3. And then how do I find a sub n? Awesome, I plug in 30. So it would be 30 times 3 minus 6. So 90 minus 6 would be 84. So we just have to simplify in here, evaluate. So you have 15 times 81. It's 15 times 81. 1,215. So that would be our sum.
But is it always going to be like the top number? Or?
Yeah. So to find n, you're using these numbers here. So it'll be 30 minus 1 plus 1. So that would just be 30. So let's say I had n sub 51 and it ends at 260. How can I figure out how many terms are in between here? What would my n be? 260 minus 51 plus 1.
Where was this formula? Because I was like, this is new.
So 260 minus 51 would be 209 plus 1, so n would be 210. So 7 says, find the common difference for the arithmetic sequence. So what are we doing to get from one number to the next? Adding 7. So what's our common difference? 7, so D is 7. For number 8, we have to write the first 5 terms of the arithmetic sequence. Yes, go ahead. So we can start by writing our general formula. So a sub n is equal to the first term. So I'll write a sub 1 plus n minus 1 times d. So our equation is 19 plus n minus 1 times -4. Distribute the -4. We would get 23 minus 4n. So that's our general equation. So to find the first 5 terms, a sub 1 is already given to us. That's 19. To find a sub 2, what do I need to do? Plug in 2 for n. So I have 23 minus 4 times 2, which is 15. Plug in 3 to find our third term. So 23 minus 4 times 3, 11. Plug in 4. 23 minus 4 times 4.
Please pardon the interruption. Softball may be dismissed at this time. Softball may be dismissed at this time. Thank you.
And then when we plug in 5, we get 3. So our first 5 terms would be these. But remember, for these questions, you have to show your work. So this is your work. So yeah, you could write it like this, or you can write it as a list, like 19, 15, 11, 7, 3. Either way would work, like this or like this. So remember, we have 2 equations for a sub n. We can use a sub 1 plus n minus 1 times d, or a sub n is equal to d times n plus a sub 0.
And how do we know which one's easier?
Either one works both times. So if you're given a sub 1, this one would probably be easier. But if it's given like as a list like this and it's easy to find a sub 0, you can use the second one too. They'll always simplify to the same thing, so either one works. All right, number 9. Use the formula for the general term of an arithmetic sequence to find the indicated term of the sequence with the given first term and the common difference. So here we have to find our general term and we have to find our 80th term. So our general formula would be a sub n is equal to a sub 1 plus n minus 1 times d. I'm going to distribute the negative 6, so a sub n is equal to negative 6n plus 1.
Do you have to simplify anything?
Yes.
So when you find
Using the second equation, we just plug in 80, so this would be a sub 80 is equal to negative 6 times 80 plus 1.
you put
80. There we go. What do we get here? Negative 479. If I did it the other way, so like for this one, it would be a sub 80 is equal to negative 5 plus 80 minus 1 times negative 6. So this would be negative 5 plus 79 times negative 6. I don't have a calculator, but what's 79 times negative 6?
negative 474.
Negative 474, and then minus 5. Yeah, so, all right, so number 10. We have to write the formula for the general term of the arithmetic sequence, then use the formula to find the 20th term. So pretty much doing the same thing here. It's arithmetic, so what are we adding to get from one number to the next? Negative 9. This one we can use the a sub 0 one. So if our first term is 10, how do we find our 0 term? We add 9. So what would our 0 term be? 19. So a sub n is equal to 19 minus 9n. Yeah.
So why did you decide to use the a sub 0?
Just to do something different, yeah.
Like either one.
Either one would work. When you simplify the first using, you would get the same thing.
But you said it's easier when it's like that. Right?
Yeah, when it's in a list like this, I think it's easier just to find the 0 term and plug that in. But either way works. Yes. It doesn't matter. Either way would work. A times n is equal to negative 9n plus 19. Same thing.
Do we gotta worry about it forever given a list that is purely one?
You could, but then it would probably ask you to find a sub 1. So we want to find the 20th term, so plug in 20. So 19 minus 9 times 20. What do we get? I think it's 161. Negative 161. So this would be our formula. This would be our 20th term.
If I solve it as doing a sub n is eliminated first.
All right, next one, 11. We have to find the sum of the first 30 terms of the arithmetic sequence. So our sum formula is s sub n is equal to
n over 2 times
it's n over 2 times a plus a sub 1 plus a sub n. Yeah.
the geometric sequences have the fraction.
Right. So remember, your sum formula is different for arithmetic and geometric. So n is our number of terms. How many terms do I have here? 30. It says find the sum of the first 30 terms. So n is 30. So I'm going to plug 30 in. 30 over 2. What's our first term? 6. How do I find what my last term is? So I have a sub n is equal to dn plus a sub 0. So I have to figure out what my general formula is to then find my 30th term. So a sub n is going to be equal to, what's d? What's my common difference? 10. I'm adding 10 each time, so 10n. And then to find my 0 term, I would go backwards. So instead of adding 10, what's 6 minus 10? Negative 4. So then to find my 30th term, I plug in 30. So 10 times 30 minus 4. So this would be 296. And then we just put this into our calculator. So be careful when putting it in the calculator. It would be 15 times 302. What do we get? 4,530. So number 12, we have to write out the first three terms and the last term of the arithmetic sequence. So starting with the first three, what do I plug in first to find my first term? Plug in 1. So this would be negative 3 times 1, which is negative 3. What do I plug in next? 2 to find my second term. So this would be negative 6. To find my third term, I plug in 3. So negative 9. So that's my first 3. And then to find my last term, what do I need to plug in? 60. Because it starts with 1 and ends with 60. So to find my last term, I plug in 60. So negative 3 times 60, which would be negative 180. So 14 says, if the given sequence is a geometric sequence, find the common ratio. How do I find the common ratio? Yeah, you can see what you're multiplying by, or if it's something that you can't clearly see what you multiply by, always do the second term divided by the first. So this would be negative 3 is my common ratio. It's in the video. We did it yesterday. So just divide the second term by the first one, or you could divide the third term by the second term. It'll give you the same common ratio. All right, so 22. We have to find a sub 1 and a sub n, given a sub 3 is 5, a sub 8 is 1 over 625 of the geometric sequence. So geometric sequence, our formula is a sub n is equal to a sub 1 times r to the power of n minus 1. So if I'm now using 8 and 3, this will be a sub 8 is equal to a sub 3 times r to the power of 8 minus 3, which is 5, yes. So I know what a sub 8 is. That would be 1 over 625. A sub 3 is 5 times r to the power of 5. So I can divide both sides by 5. When I have a fraction in a fraction, keep change flip. So it's 625 times 5. 1 over 3,125 is equal to r to the 5th power. Now hopefully this works out nicely. So when I take the 5th root of both sides, what do I get? 1 over 5? Amazing. So r is 1 over 5. So a way that you could put this into the calculator would be 1 over 3,125, and then put it to the 1/5 power. But make sure you put the 1/5 power in parentheses because you're dividing. So this would be how you put it in the calculator. All right, so r is 1/5. So we can find a sub n now, or we can find a sub 1 because we need a sub 1 for a sub n. So let's figure out what our a sub 1 is. So what can I use for a sub n? I'm trying to find what my first term is.
I just counted back from a sub 3.
You can do that. Or
You could plug in a sub
to
3.
do it mathematically, we can plug in a sub 3 is equal to a sub 1 times r to the power of 3 minus 1. So it's 3 minus 1. So a sub 3 is 5. A sub 1 times r would be 1/5 to the power of 2. So 5 is equal to a sub 1 times 1 over 25. How do I solve for a sub 1?
Divide by 1/25.
Or I can multiply both sides by 25. But yes, you can divide by 1 over 25. So it'll cancel out there. 5 times 25 is 125. So a sub 1 is 125. That is our first term. Now we can use our first term to plug it into the formula to find a sub n, because a sub n is just asking us for the equation. So a sub n is equal to 125 times r to the power of n minus 1. What's r? 1/5. So that is a sub n. Just as like a little reminder, note, study tip, I guess, there's 5 formulas that we need to remember. So we have arithmetic, which a sub n is equal to a sub 1 plus n minus 1 times d. We also have the sum of an arithmetic sequence, which is n over 2 times a sub 1 plus a sub n, so the first times the last. And then we also have geometric formulas. So our a sub n for geometric would be a sub 1 times r to the power of n minus 1. Then we have 2 sum ones for geometric. So that would be finite. So when it has an ending, it's s sub n is equal to a sub 1 times 1 minus r to the nth power over 1 minus r. And then infinite is the one that's a little bit easier. So it's a sub 1 over 1 minus r.
Can you also write the end one? The end equals.
So pretty much the same thing here is a sub n is equal to n times d plus a sub 0, that one.
Is that what we did? It was like the n minus 1 plus 1.
Yeah, so when we have a sum of, either one would work when you're dealing with the sum.
Okay.
To find n, when it's the little squiggly line, you take the last one minus the first plus 1.
A sub 0 is just.
All right, 15. We have to write the first 5 terms of the geometric sequence. So first, I want to come up with my general formula. So a sub n is equal to, this is geometric now, so it's a sub 1 times r to the power of n minus 1. So a sub n is equal to 3 times, what's our ratio? 1/5 to the power of n minus 1. So to find the first 5 terms, we just plug in 1 through 5. So a sub 1 would be 3 times 1/5 to the power of 1 minus 1, which would be 3. It's given to us here, but we can find it that way. A sub 2, we plug in 2, so 3 times 1/5 to the power of 2 minus 1. So this would be 3 over 5. A sub 3 would be 3 times 1/5 to the power of 3 minus 1, so 3 over 25. A sub 4 will be 3 over 125. No, yeah, 125. And then a sub 5 would be 3 over 625. Yes?
On the test, do we have to show the equation, or can we just multiply 3 by 1/5 and then?
You have to show your work. It'll probably ask you for the equation as well as the first 5 terms. Logan? You will not have the formulas, so you have to remember them. Yes?
And when they ask for the equation, whatever you something based off what we're given, we should plug in, right? It's not just, okay, the formula is A equals A1. Like, we plug in the numbers.
Yeah, plug in what it gives you, but then like sometimes you might have to find what you're missing. So 16, use the formula for the general term of a geometric sequence to find the indicated term of the sequence when given the first term in the common ratio. So we need to come up with our formula, and it is geometric. So a sub n is equal to a sub 1, which will be 7, times our common ratio, which is negative 2 to the power of n minus 1. So that's our general equation. And then we also have to find the fourth term. So a sub 4 is 7 times negative 2 to the power of 4 minus 1. So this will be 7 times negative 8. So negative 56. Remember, PEMDAS, order of operations, you have to do the exponent first, then multiply the 7. Yes, yes. All right, so 17, we have to write a formula for the general term, the nth term of the geometric sequence. So again, we need our formula, so that would be a sub n is equal to a sub 1 times the ratio n minus 1 to the power of n minus 1. So our first term is what? 6. How do we find our common ratio? We would do 12 divided by 6, which is 2. So 2 to the power of n minus 1. So your general form will always have an n in it. That's your variable, so you can plug in whatever n to find that value. Any questions here? 18. So for this, we have to determine if it's arithmetic, geometric, or neither, and find the common difference or the common ratio. So we can plug in values to see. So a sub 1 would be 3 times 1 minus 2, which is 1. A sub 2 would be 3 times 2 minus 2, which is 4. A sub 3 would be 3 times 3 minus 2. 3 or 4-ish. So this is 7. So what am I doing to go from one number to the next? I'm adding 3.
So when I look at this, like the top, I'm thinking, okay, addition or subtraction, arithmetic, and then the other one I see multiplication or an exponent, and I'm thinking geometric. Is that normally how it's going to go?
You can think about it that way too.
Like, am I going to do?
So, yes. What is my common difference? 3. Yeah. Because it's, remember, our formula is d times n plus a sub 0. So d is what gets multiplied to n. So then for the next one, again, I can plug in terms. So a sub 1 would be 4 to the first power, which is, when she comes back, 4. A sub 2 would be 4 to the second power, which is 16. A sub 3 will be 4 to the third power, which is 64. So what am I doing to go from one number to the next? Multiplying by 4. So what? Is this geometric, arithmetic, or neither? Geometric. And what's my common ratio? 4.
So when I saw this, I thought, okay, that
If you had something like n squared, if I plugged in 1, that would be 1. If I plugged in 2, that'd be 4. If I plugged in 3, that's 9. So am I multiplying by the same thing to get from one number to the next? No. Am I adding the same thing to get from one number to the next? No. So this would be neither.
is that the only circumstance you get neither, or just if you don't see a pattern at all?
If you don't see a pattern. If you're not adding the same number, not multiplying the same number, it would be neither. So, I mean, it could look like this. It could look like n squared over n minus 1, something like this. They could look different. Yeah, we did something like this, I think in the beginning of the review, and it ended up being neither also. All right, 19. Find the sum of the first 13 terms of the geometric sequence. So here we need our sum formula for geometric. What is that?
A sub 1 times 1 minus
it's 1 minus r to the nth power, because here, for geometric, we have r instead of d, but yes. Over 1 minus r. So we can start by plugging in everything we have. We're looking for the first 13 terms. So n would be 13. What's our first term? 5. So 5. Yes.
Because it's infinite, isn't it? A1 over.
So even though it has the dot, 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 it may look infinite, but it asks us to add the first 13 terms. So it has an ending. So this one's a little bit tricky. So minus, what is our common ratio? What are we multiplying to get from one number to the next? -3. So this would be -3. And what's n? How many terms? 13. Over 1 minus -3. So be careful when putting this in your calculator. You have to do the exponent first. And then do 1 minus that number, multiply it by 5, and then divide it by 4. So what do you get for this one?
$2,905.
1992
905.
905. There you go. Yes. Any questions here?
On the review, there's nothing that doesn't start with 1 on the.
So what Ashley was talking about was one like this that didn't start with 1 on the bottom. So remember, I'll show you once we start doing it, but we have to find the sum of the first n terms. So is this finite or infinite? Finite, because it has an ending. So it's s sub n is equal to a sub 1 times 1 minus r to the nth power over 1 minus r. So to find our first term, it doesn't matter what this number is, you always plug that into your variable to find your first term. So if this said I is equal to 4, that means we start with 4, so we would plug 4 in. So that would be our first term. You always start by plugging this number in.
So I thought that on like the sum where it's.
So when we plug in 1, we get 8. So this would be 8 for our first term. And then what's our ratio? 4. So it's whatever has the exponent. So it would be 4. And then how many terms do I have here? 5. To find that, you would do the last minus the first plus 1. So that would just be 5. So our exponent is 5. And then over 1 minus our ratio, so 1 minus 4. So then we put this in the calculator, and what do you get? 2,728. So we have to find the sum of the infinite geometric series if it exists. So what's our infinite formula? S sub n is equal to a sub 1 over 1 minus r. So what's our first term? 48. And 1 minus our ratio. What's our ratio? If it says exact, it can't be a decimal. So here we are multiplying by what to get from one number to the next? 1/4. We can find that by dividing 12 by 48, which would be 1/4. So our common ratio is 1/4. Now, if the question on the test does not say exact, you can put this in your calculator, but if it does, we have to simplify it by hand. So on the bottom, I need a common denominator, so I'm going to make this 4 over 4. So it'll be 48 over 3/4.
So if that's if it says
Exact.
It doesn't say exact. Yeah.
Right. So if it says exact, we have to do it this way. What do I do if you have a fraction inside a fraction? Keep, change, flip. So we keep the top, change multiplication, flip the bottom. 3 goes into 48 16 times, so this would be 16 times 4, which is 64. So that would be our sum. All right, so one question that was not on the review.
Can you please send Madison to Moscow to the advancement office room 117?
Yes. Is a recursive one. So recursive is when you have to use the number before and plug that in. So an example would be if it gives us our first term. So let's say our first term is 3. And then it says a sub k plus 1 is equal to a sub 1 plus 2. Oops, a sub k plus 2. There were problems like this on the website, and there were problems like this from their notes.
Geometric?
You used the number before, so this was recursive.
You gotta look up recursive function.
Yes. That's why I'm doing it now. So to find a sub 2, this just tells me that I have to use, if I use a sub 1, if I plug in 1 for k, let me change the color. So if I plug in 1 for k, that's giving me, what's 1 plus 1? 2. So that's giving me a sub 2. So a sub 1 is 3, so I would do 3 plus 2, which is 5. To find a sub 3, I take 5 now and plug that in, so it would be 5 plus 2, which is 7. To find a sub 4, I use the one before, plug that in, so 7 plus 2, which is 9.